Welcome to IM1 11.1, video number 1 of 2. We got 5 boxes to talk about today, and the big topic for us today is performing translations. So first of all, there are 4 types of transformations in geometry that we study a lot, and here are the 4 types. Okay, these are the 4 big ones. The first one is called a translation. And that's the main one that we're going to focus on today. There is a rotation. And we're going to focus on that one the next video. There's a reflection. And lastly, there is a dilation. Or dilation. I said not dilation, sorry. It's dilation. D-I-L-A-T-I-O-N. Okay, so today our main focus is going to be here on this guy, a translation, which is the most basic, and basically a translation is just moving an object from one spot in the coordinate plane to another spot in the coordinate plane. So honestly, if I were to draw like a little picture of a triangle right here, like this, and I could even color it in for you, something like this, okay? And if I took this guy right there, okay, and just moved him over to right about there, then that would be an example of a translation. So what I'm going to do is I'm going to do edit copy and edit paste, okay? And so literally again, okay, if I just take this guy and move it from one space to the other, then I have completed a translation. So if I'm just moving it in this direction just a little bit, from there to there, and from there to there, and from there to there, that would be considered a translation. So we're just moving objects around from one spot in the location of the coordinate plane to another. Okay, box 2, how do we perform a translation? So what are we trying to do when we're saying, how do we perform one of these things? So for us, the definition is going to be a translation. So that's what goes here. So a translation moves every point of a figure the same distance in the same direction. Okay, so that doesn't seem very challenging or hard, and it's not. This concept's not too tricky. The only tricky part is understanding what vectors are. So here is the 3 steps that you're going to use to do a transfer or translation every single time. Number 1, we're simply going to plot the points of the preimage. Now, what is this word here? The preimage is a fancy word for just the original shape, okay? So when we say preimage, we're just talking about the original shape. Step number 2, we're going to use the component form of a vector, and we're going to move all the vertices in the original shape. Okay, step number 3, we are going to draw the image, and the image right here is the fancy word for the new shape. Okay, so let's review these again. We're going to plot the points, we're going to use a vector, and then we're going to draw the new shape. So let's talk a little bit about what a vector is, all right? A vector in component form is just a ray in a specific direction. That's all it is. So for example, this right here would be considered a vector, and we would call that vector PQ. And the way that we would write that is we would say vector PQ, and it would have a little, and it would almost look exactly just like a ray would. All right, so vector PQ. Now, in a vector has an initial spot, and it has a terminal spot. So the first one is your initial spot, your initial point, I should say. And where it ends on the little arrow, that's your terminal point. Okay, so why are these things important? These things are important because it tells you where to start and where to stop. The other important thing about a vector is the components. So the components of this would be written like this: 5, 3 with these little arrows. And what does this mean? This means that we go 5 units in the x direction and 3 units in the y direction. So that means I'm going over 5 and up 3. It's the exact same idea as slope. So the only hard part is just getting us some use to the notation. So when we say in component form, this is what we're referring to right down here, in component form, okay? So if I gave you a vector that was like this, 6 comma negative 1, that would mean 6 units in the x direction, negative 1 unit in the y direction, and that would be a vector. This would be your initial point, and then negative 1 would be your terminal point, okay? That's everything you gotta know for box number 2. All right, here we go. Box number 3, let's do an example together. I'll do this in like a purple color for you. It says, translating a figure using a vector. Okay, so the vertices of triangle ABC are 0, 3, 2, 4, and 1, 0. So let's go ahead and draw that first, triangle ABC. So 0, 3, so 0, 1, 2, 3. So that's right here. That is point A, that's 0, 3. 2, 4, so 1, 2, 1, 2, 3, 4. Right there, that is point B, 2, comma 4. And then, of course, we have 1, comma 0. 1, comma 0 will be right here, 1, comma 0. There's point C. So I will draw my triangle just like this, all right? And that is called the pre-image, P-R-E-I-M-A-G-E. Again, the pre-image is just the original shape. So if I wanted to kind of color this in a little bit, that right there, the pre-image would be my original shape. Now, the question is telling me to translate this triangle using a vector 5, negative 1. All right, so what does this mean again? Don't forget that this is just your component form of a vector. So that means I go 5 units in the x direction, 1 unit in the y direction with every single point. So for point A example, I would go 5 units in the x direction, so 1, 2, 3, 4, 5, negative 1 unit in the y direction down here, and that would be A prime. So 1, 2, 3, 4, 5. So right down here, this would be what we call A prime, meaning it's the new spot. And I have been translated by vector 5, negative 1. So this right there is that vector 5, negative 1. And we're going to do that with all of the points. So B is going to be 1, 2, 3, 4, 5, negative 1. So B prime is going to be right there. And then C prime again is going to be 1, 2, 3, 4, 5, negative 1. Boom. There's C prime. And again, notice that all of these are vectors, and they've been translated all this way. And notice that those vectors are all parallel. Let's use a different color here. So this would be my new shape, right? And right there. And I could shade this guy in right here. And this would be the image. The image is the fancy word for the new shape. Okay, so that is my image, and my pre-image was the original shape. And that's how we translate a figure using a vector. Okay, box number 4. You can kind of see 4 and 5 together here, but box number 4 is writing a translation rule. So now what they want you to do is kind of go one step further and say, okay, we gave you this original triangle, which is in yellow, and now, or sorry, other way around. Let me get that. Let me try that again. We gave you this original triangle, and it ended up in this this spot over here. So this triangle over here is our pre-image, and then this red triangle over here is our image. So the question is, what is the rule on how we would get to that spot? Okay, so if you're thinking about it, take one specific point to focus on. So let's focus in on maybe vertex A, okay? To get from vertex A, which is right here, all the way over here to vertex A prime, what do I have to do to get over there? Well, I have to go 1, 2, 3, 4 units in the negative x direction, and I have to go 1 unit in the positive y direction. So if I was going to draw a vector from here to here, okay, that vector, and this was vector P, for example, and then vector Q, okay, so initial and terminal, then vector PQ would have components -4 and then 1. because we are going negative 1, 2, 3, 4 in the x direction, so backwards, and then 1 up. So that vector would translate all of these points from there to there, and then from there to there. So every single x that we would have that we're starting with, we would subtract 4, and every single y that we would start with, we would add 1. So how do we write this in a general rule? So the general rule needs to look something like this. If you start with an x and a y, like give me any x and y, what then do I translate it into? Well, I take every x that you give me and I subtract 4, and then I take every y that you give me and I add 1. So that right there is the rule for every single xy. So you give me an xy, I will then apply this rule. I will subtract 4 from my x. I will add 1 to my y. And that is how I can get from triangle ABC to triangle ABC prime, also known as the pre-image and the image. So that is what they mean by what they say by give us a translation of a rule. Okay? All right, last box here, box number 5. It says graph the quadrilateral ABCD with vertices A at negative 1, 2. Okay, negative 1, 2. That's right there. There's A. B is negative 1, 5. Negative 1, 2, 3, 4, 5. Right there. There's B. All right. C is at 4, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So C is up here somewhere. And then D is at 4, 2. 1, 2, 3, 4, 1, 2. All right. So here is my quadrilateral, ABCD in the plane. Okay. And let me shade it in just a little bit here, like this. Okay. It says graph the quadrilateral. We did that. And its image after translating it according to this rule. So pay close attention to what this part says right here. It says, for every x, we are going to add 3, and for every y, we're going to subtract 1. Okay, so every x, we're going to add 3, and every y, we're going to subtract 1. So, let's see here. If I start with A, for example, I'm going to add 3 in the x direction, 1, 2, 3, and then subtract 1, so that would be A prime. All right. B, same thing. 3 in the x direction, 1, 2, 3, and then down 1. That'd be B prime. C, 1, 2, 3, then down 1. That'd be C prime. And then D, 1, 2, 3, down 1. And that would be your D prime. So that's, if I redraw this again like this, okay, this is the image, and the purple one was the pre-image. And we've been translated by that vector right there of 3 and negative 1. Okay, that's everything you need to know for translations. See you in the next video.